So yes, Tejeshwar, please introduce yourself.
So myself Tejeshwar, I am from Andhra Pradesh,
Hmm.
and I have graduated from the JN2 College of Pulivendala. It is autonomous college,
Hmm.
and I am the topper of my batch. And I have completed my diploma from the Government Polytechnic College, where I am the second in my batch, second ranker in my batch, and I have completed my schooling from the a small village. The school name is St. Joseph High School. Here also I have a good academics records, and I was preparing for government jobs last 2 3 years, and I have missed Barc scientist exam by 1 mark in last attempt. And this is my first interview first interview, and this is was a Barc interview also, which I have selected as a first interview. So,
Okay.
and my hobbies are mostly I will use the watching videos and doing some chatting with others. So
Okay. Fine. Like, are you basically are you basically interested to join Barc technical officer, or you want to join scientific officer?
no, sir. I can, sir. If I was eligible for the scientific officer, I can definitely join for scientific officer. So
Sir, then Tejeshwar, you will to leave, right, as a technical officer. Then, as you will be leaving, so this post basically you are going to waste. Why?
no, sir. I am not much sure about that, because whatever my preparation was, it is up to for technical officer only. I was not having the good preparation for the scientific officer, so I can hope for this year as a technical officer. So
Okay, that's fine. Please tell me, like, which subject basically are your favorite subjects?
my favorite subjects are basic thermodynamics, sir,
Okay.
and fluid mechanics,
Hmm.
strength of materials,
Yes.
and finally heat transfer, sir.
Great. So basically all the four subjects, right? So shall I start with thermodynamics or shall I start with heat transfer?
Yes, sir. You can any subject, no problem.
So no problem, right? So I want every answers to be answered by you, right? Every questions to be answered by you.
Yes, sir. Yes, sir.
Fine.
Yes, sir. Yes, sir.
Okay. Yes, Tejeshwar. So first of all, tell me, like, what is the basic difference in thermodynamics and heat transfer?
Sir, the basic difference is one thing is in thermodynamics we deal only with the that means state of equilibrium conditions,
Hmm.
and whereas in the heat transfer we only discuss at what rate the heat transfer is taking place, and what rate the equilibrium state is reaching the system. That is the basic difference, sir.
Okay. Tell me about the laws of thermodynamics.
Laws of zeroth law, first law, second law, and third law, sir.
Tell me more about second law of thermodynamics.
Second law of thermodynamics, also known as directional law, sir,
Hmm.
and it is also called as quality law.
Hmm.
Because in the first law we doesn't know how the heat is how the we in the first law we don't know either heat is flowing or work is doing. We only know that complete heat is converted into work, or the total energy can be converted into one form to other form. We don't know the how it will happen. But in the second law we came to know the heat is flowing from higher energy to lower energy, and by doing some work, and heat can also flow from lower energy to higher energy by having some external amount of heat, external amount of work that can be possible. That is helped by knowing the second law.
So as we were having first law, so what are, like, there were some consequences, right? So are you aware of the consequences? That's why second law of thermodynamics
Yes,
came
sir.
into
Yes, sir.
the picture, right? So what were the
Yes,
consequences
sir. Yes,
of
sir.
thermodynamics?
It doesn't give the direction, sir. One is doesn't it doesn't give the direction. Yeah, how it will happen.
Only one consequence.
No, sir. I was remembering, but one I have in my mind. Let me think over it, sir, because I was not revised the things. Let me try to recall it.
We call it,
Mm,
and next time first think and then answer.
okay, sir.
Hmm.
Sorry, sir, I was unable to recall. After revision, I can do so. I was not much revision of the subject. I was doing
PMM1 is not
from
possible.
the.
PMM1 is not possible.
Sir?
Perpetual motion.
Yes, sir, yes, sir. PMM1 is. Yes, sir, yes, sir. PMM1 is not possible. Yes, sir. Yes, sir. Without having heat supply, it doesn't do any work. That is the PMM1, sir. Without heat supply, the machine continuously doing work. It is also not possible because it violates the first law of thermodynamics.
Great. Okay. Next question I will moving. Like, tell me what is quasi-static process? What do you mean?
Quasi-static process.
Yes.
Quasi-static process is very slow process, sir. That means it will reach. Every point it will equilibrium, and the process very slow, and it is also reversible process, sir.
What do you mean by reversible process and irreversible process?
Reversible process means the process happening from one state to another equilibrium state. There is no losses in the system. There is no losses from the system, sir. Either if losses are there, then those losses are recovered by returning to original position. That means from second state to first state, those losses are recovered. That means there is no external effect from the for the surroundings. Whereas in irreversible, there is an external effect on the surroundings. So that means that doesn't regain in the coming to original position in the irreversible process. We can get in reversible process while returning to original position.
Okay. Tell me like some applications where do we use second law of thermodynamics? What are the applications of second law of thermodynamics?
Yes, second law of thermodynamics is used in the Clausius statement like heat engines, heat engines, and also refrigerators,
and
heat pumps, and we need to find the entropy of the system. Those applications, sir.
Okay, so tell me, basically COP and efficiency. Where do we measure efficiency and where do we measure coefficient of performance? And what do you basically what is the significance of coefficient of performance?
Generally, efficiency is less than 1, sir, and it is only calculated for the work producing devices. Like work producing devices, we can calculate efficiency, sir. According to thermodynamics, what are the devices producing the work? We can find efficiency with here. And whereas COP, we can get COP in the work consuming cycles like VCR cycle or VAR cycle. So
okay, so as mentioned VCRS cycle, right? Tell me what can you draw the diagram of VCRS?
Yes, sir, definitely. You mean that PV diagram or schematic diagram, sir?
The schematic diagram. First of all, schematic diagram of VCRS. Okay, vapor compression refrigeration cycle, as well as you can draw, as well as you draw about VARS, right? Vapor absorption refrigeration cycle.
Okay, sir, definitely, sir, definitely.
Now, have you drawn?
Yes, yes, I am drawn. So I have drawn so showing with me. So
Tell me.
does it visible? Does it visible, sir?
No, it's not visible. Put somewhat back. I think so. Camera is not good.
Yes, sir. So it is not good for me. Okay, let me
No problem.
show here like this, sir. Okay,
Yes.
let me show like this.
Just switch the camera. Yes, yes. Yes, it's visible. Okay.
This schematic diagram, sir.
Can you explain? Just tilt it. Okay. No, just tilt right. Tilt right.
Wait a minute, wait a minute, sir. I have auto rotate. I have kept. Wait a minute, sir.
Yes.
Yes, no, okay. Let me check back camera. Okay. Yes, sir. No, you visible, sir.
Yes, compression is there, expansion valve is also there, evaporator is also there, condenser is also there. Right. Now, what are the
Yes,
functions
sir.
of evaporator and what are the functions of condenser? Can you comment on that?
Yes, sir. Evaporator. In common sense, that means evaporator is like where we kept food items, sir. That is where which we need to make cool.
For evaporator or condenser? Does evaporator
Evaporator, sir. Evaporator.
Okay.
Yes, sir. In evaporator only our food items can be kept, sir.
Huh.
And the heat, whatever the heat available at the food items, that can be taken by the refrigerant flowing over in the cycle. That can be absorb the heat from the items, food items, and it go for phase change, and after that it compression and heat rejected to the surroundings in the condenser, sir.
Okay. You have also drawn PV diagram, right? So PV diagram, you have drawn it, right? Very
Yes,
good.
sir. Yes, sir.
Just show me.
Yes, sir.
Okay, it's fine, fine. No problem.
Sorry. It is TS diagram, sir. TS diagram. Sorry, TS diagram.
That only.
It is TS diagram.
Okay, so I think I should move on to the next subject. Which subject to mention? Heat transfer,
Okay,
right?
sir.
Okay.
Yes,
So
sir. Sir.
tell me the applications of heat transfer.
Application, sir.
Yes. You can switch on your yes.
Yes, sir.
Tell me the applications of heat transfer.
Yes, applications of heat transfer. One is we can apply in the fins in the where in the we can also use in the wires, electrical wires, and also in our power plant, like where we have like condensers and condenser. In the condensers also we can use the heat transfer concept, sir.
In evaporators, can we not use the concept of heat?
Yes, sir. We can use because in the power plant the heat available we need to utilize the heat into work. So we need to make the heat loss should be less.
Okay, Tejeshwar, no issues. Okay. Tell me about the critical thickness, as you mentioned electrical wire, right? So
Yes, sir.
just let me complete the question.
Critical thickness.
That you answer.
Okay, sir. Okay, sir.
Don't behave like a child.
Okay.
Don't behave like a child.
No, sir. No, sir. Okay.
You are a graduate, right? Sure.
Yes, sir.
Next thing is, tell me about the concept of critical thickness in the case of wires and in the case of pipes.
Okay, sir.
Tell me that, and after that, the next question I'm asking you.
Okay, sir. Generally, critical thickness is the critical radius of thickness is the thickness where we need to make insulation.
Let me correct my statement. Sorry, it's not critical thickness.
Yes.
Critical radius of insulation.
Critical. Yes, sir. Yes, sir. Critical radius of insulation means at what amount of insulation we need to make for the heat losses or heat transfer from the system. When we go for wires now, sir, we need to make the more heat loss from the wires, sir. Then only the more current can be flow. So the critical radius of thickness, whatever the insulation we are making.
Explain why graph.
Okay, sir. Okay, sir. Let me give a graph. Okay.
Explain why graph.
Okay, sir.
And Tejeshwar, when I will be giving you feedback, the very first point is don't behave like a child. You are going to interview.
Okay, sir.
When you are going to interview in front of all the Barc scientists, they are 60 years of age.
Sir.
If you behave such things, na, they won't
Yes,
tolerate.
sir.
They will send you out, Sida.
Yes, okay. Okay, sir.
If you think I am rude, yes, I am rude, but I want selections.
No, sir. That is helpful for me in the interview, sir. It's no problem, sir. That whatever the mistakes I am making, that only I need to learn from the mock interview, sir.
Great.
That is positive feedback for me, sir. I know I don't get any frustrated over it, sir. Because this is my first interview, so how to behave, I don't know exactly in the interview. So I was learning from you from my mistakes, sir.
Okay, you just draw the diagram.
Yes, sir. Sir, this is the case for wire, sir.
Which one?
This is the case as increasing the radius of insulation up to critical radius. The heat is going for increasing up to maximum, sir.
Okay, and in the case of pipe?
In the case of pipe, it is from critical radius of thickness to next. As we are increasing above critical radius, that means whatever the radius of insulation should be greater than critical radius. Then only the heat losses should be less. Then the heat can be utilized for our power generation, sir.
Okay. Why the critical radius concept is not applicable for flat plates?
For the flat plate, okay. That means if you use the critical radius of thickness, like any critical thickness also, if we increase like that, then there is chance of one is conduction resistance and the convection resistance will be decreases, sir. As the area exposed to the convection should be is going to be decreased. Due to that, heat loss will be less, sir.
Great, I am getting you. Okay. So overall, I will be concluding your interview. Okay, just note down your feedback. Note down your feedback.
Okay, sir, sure. Yes, sir.
The very first thing is the presentation skill.
Okay, sir.
The second point is body language.
Okay.
The third point is when you are you are having conceptual knowledge. I understand that you are having a conceptual knowledge, but that conceptual knowledge you have to express in such a way with that the interviewer also likes your concept, right? उन्हें भी पसंद, sorry, they also wants to like the concept. You explain them in such a manner. Fluency will play a major role. Fluency will play a major role. You are having exceptional knowledge. Knowledge is not the problem. Knowledge is not the problem. The main problem is behavioral skill. Communication skills also are fine, no problem. You will be giving interviews in the English only, no issues. Repetitive use of sir should be avoided. Repetitive use of sir should be avoided. Use once, sir, I know this answer. The next question is, do not say to sir that sir, let me think. First, let me think, and then I will be answering. Do not say that thing. समझे क्या? Are you getting? You said
okay, sir. Okay.
Are you getting? You said to me, sir, I am not understanding when I asked you the consequences of first law of thermodynamics. Don't say to them. First, if you don't know the answer, first think. First think, take a minute, take a break, take a break of 1 minute. First think and then only answer the question.
Okay, sir. Okay, sir. Definitely, definitely.
Otherwise, it will give you negative marks. Total of 8 to 10 panel members are there. Okay. Use of proper board should be there, where they will be providing you a board, whiteboard basically, and use of markers, right? So the main thing is use of board. You must know how to use the boards, and whenever like as 1 second. Okay, you have drawn TS diagram, right? And you have mentioned PV diagram over there. So keep an eye contact, that keep your presence of mind there, that you are drawing the correct diagram, right? Okay, so I think so that's from my side, because conceptual knowledge you are having much. Just revise the thing. Revision is must. I have provided the links, and I have provided the links of Lamia Nasim also. You can go through with that link. First of all, you complete those 85. The same series I am also going to start, but in the animation way. I was going to start that series, but I'm not getting time, so I haven't started. Otherwise, I was starting from 15th onwards. Okay, no issues. Any questions to me?
Yes, sir. Yes, sir. The feedback is very helpful for me, sir. This is my first interview now, so I was somewhat excited in my sense, sir. So I need to keep calm while delivering the question, and I need to maintain like some what we can say, that excitement should be controlled, sir. Because this is my first interview, I was excited, so that was the problem, because I was going very fast manner, sir.
Right. Okay. So I will be ending your session.